18, 1980. In a matter of minutes, 1,300 feet of summit torn away, 230 square miles of ancient forest erased, more than 200 homes destroyed, 57 people killed, 185 miles of highway buried, the energy released 1,600 times the force of the bomb dropped on Hiroshima. 8:32 in the morning. Mount St. Helens split open sideways and fired a wall of superheated gas and rock across the state of Washington. It was the deadliest and most destructive volcanic event in the recorded history of the United States. 13 hours before any of that, on the evening of May 17th, David Johnston, 30 years old, a volcanologist with the United States Geological Survey. He was sitting alone at an observation post 6 miles north of a volcano that hadn't erupted in 123 years. At 8:32 a.m., a magnitude 5.1 earthquake shakes the mountain, and the entire northern face, 2.5 cubic kilometers of rock, ice, and earth, begins to slide. It is the largest landslide ever recorded in human history. What happens next has never been seen before. Not by any scientist, not by any instrument, not in any textbook ever written. The landslide uncovers a superheated body of magma buried inside the mountain, and the pressure that has been building for 2 months explodes. Not upward, sideways. A wall of superheated gas, pulverized rock, and ash tears northward at more than 300 miles per hour, nearly the speed of sound. Its temperature reaches as high as 660 degrees Fahrenheit. Within minutes, it flattens 230 square miles of ancient forest, snapping trees 2 meters thick like matchsticks, and buries everything in its path under a layer of scorching debris. 4 billion board feet of timber, enough wood to build 300,000 homes, gone in minutes. And David Johnston, the man who had warned everyone this would happen, has just enough time to grab his radio. His last words reach the USGS headquarters in Vancouver, Washington. 5 words. 5 words that would become the most famous final transmission in the history of volcanology. Vancouver. This is it. But to understand what happened on that day, you have to go back. Go back 123 years to 1857, the last time Mount St. Helens made a sound. After that final eruption, the mountain fell silent. Decade after decade, it slept. Forests grew thick on its flanks. Lodges were built in its shadow. Fishermen cast lines into Spirit Lake at its base. The volcano became scenery, a postcard, a place for picnics. No significant volcano had erupted in the continental United States since Lassen Peak, California, more than 60 years before. To most Americans, volcanoes were something that happened in far-off countries, not in their own backyard. But beneath that silence, the geology never stopped. Mount St. Helens sits atop the Cascadia subduction zone, where the Juan de Fuca tectonic plate dives beneath the North American plate. As one slab of the Earth's crust slides under another, rock melts into magma, and magma rises. For over a century, that magma had been quietly accumulating, miles below the surface, building pressure in a chamber no one could see. Then, on March 16, 1980, a series of small earthquakes rattled the mountain, the first tremors in over 100 years. 4 days later, a magnitude 4.2 quake struck beneath the peak, strong enough to send snow avalanches cascading down the slopes. By the end of March, steam and ash were venting from the summit. By mid-May, scientists had recorded more than 2,800 earthquakes beneath the volcano. And then came something no one had ever seen on an American volcano. The north face of the mountain began to bulge, not by inches, by feet. Every single day, the rock face pushed outward by 5 to 8 feet. A visible, measurable deformation that meant only one thing. Magma was forcing its way into the mountain's core, inflating it from the inside like a balloon made of stone. By May 17th, The day before the eruption, that bulge had displaced more than 450 feet of solid rock outward from where it had been just weeks before. The mountain was no longer sleeping. It was holding its breath. David Alexander Johnston was born on December 18, 1949, on the south side of Chicago. The son of a middle-class Illinois family, he grew up in Oak Lawn, a suburb where volcanoes existed only in textbooks and television specials. But Johnston was drawn to the earth from the beginning. He earned his bachelor's degree in geology from the University of Illinois with highest honors, then moved to the Pacific Northwest to pursue his master's and doctorate at the University of Washington. His specialty was volcanic gases, the invisible, deadly chemistry that leaks from the earth before an eruption. It was meticulous, dangerous work, and he was one of only 2 scientists at the USGS trained to do it. Before Mount St. Helens, Johnston had studied the Augustine volcano in Alaska, an explosive stratovolcano with a violent history. That experience had taught him something that most American scientists at the time did not fully appreciate, that the beautiful, snow-covered peaks of the Cascade Range were not gentle mountains. They were loaded weapons. When seismic activity began at Mount St. Helens in March of 1980, Johnston was one of the first USGS geologists on the scene. Standing in a parking lot at the timberline, with Smoking Peak looming behind him, he told reporters something that would prove, tragically, prophetic. "We are standing next to a dynamite keg, and the fuse is lit." Not everyone wanted to hear that. The mountain sat in the middle of valuable timber country. Logging companies were losing money. Locals were impatient. There was enormous pressure on authorities to shrink the restricted zone and reopen the area. Johnston and his USGS colleagues pushed back hard. They lobbied officials to maintain the closure. They argued that the volcano was capable of something far worse than anyone was preparing for. Colleagues later said Johnston feared Mount St. Helens more than any volcano he had ever studied, that he sensed something uniquely dangerous in the way the mountain was behaving. On the evening of May 17th, Johnston made a quiet decision. His graduate student, Harry Glicken, had been manning the Coldwater 2 observation post, a small trailer on a ridge about 6 miles north of the summit, for 2.5 weeks straight. Glicken needed to travel to California to meet with his doctoral advisor. Johnston told him to go. He would take the shift himself. That night, 2 female researchers, Carolyn Dreger and Mindy Brugman, arrived at Coldwater 2 planning to camp nearby for their fieldwork. Johnston warned them it was not safe. They moved on. He spent the night alone. Sunday morning, May 18th, the sun rises over the Cascades into a flawless blue sky. At the Coldwater 2 observation post, David Johnston begins his routine measurements. Laser readings on the bulge, seismic data, gas levels, nothing unusual. The same data he has been recording for weeks. At 8:32 a.m., the mountain shudders. A magnitude 5.1 earthquake strikes directly beneath the summit, and the bulge, 450 feet of overextended, fractured rock on the north face, lets go. 2.5 cubic kilometers of rock. The entire northern flank of the mountain begins to slide downhill. It is the single largest landslide ever measured. The collapse races down the slope at more than 150 miles per hour, filling valleys, burying Spirit Lake, and slamming into ridges miles away. But the landslide is not the catastrophe. The landslide is the trigger. When the north face slides away, it removes the cap that has been holding back the superheated cryptodome, a pressurized mass of molten rock and steam that had been inflating inside the mountain for 2 months. With the weight suddenly gone, that trapped energy decompresses. Instantaneously, the explosion does not go up, it goes sideways. A pyroclastic surge, a superheated avalanche of gas, ash and pulverized rock at more than 300 miles per hour and up to 660 degrees Fahrenheit, erupts laterally from the shattered mountainside. It overtakes the landslide. It reaches speeds approaching the speed of sound. It flattens everything in a 230 square mile arc to the north. Entire old-growth forests, centuries of trees standing 200 feet tall, are snapped at the base and laid flat in perfect radial lines pointing away from the crater, like the hands of a clock blown backward. The blast reaches Coldwater 2 in under 30 seconds. David Johnston sees it coming. He grabs the radio microphone. In the final seconds of his life, he transmits 5 words to his colleagues at USGS headquarters. Vancouver. This is it. The transmission cuts to static. Within 15 minutes, a column of ash rises 80,000 feet into the atmosphere, higher than commercial jets fly. For 9 straight hours, the volcano feeds that column, pumping 540 million tons of ash into the sky. And then something defies logic. The blast is heard hundreds of miles away, in British Columbia, in Montana, in Idaho, in Northern California. But in Portland, Oregon, just 50 miles to the south, people hear nothing at all. The sound waves refract off layers of the atmosphere, skipping over the closest cities and landing in the most distant ones. Even the noise of the eruption breaks the rules. The city of Spokane, 250 miles to the east, goes dark at midday. Ash falls in 11 states and 5 Canadian provinces. It crosses the continent in 3 days. It circles the globe in 15. When it is over, Mount St. Helens has lost 1,300 feet of its summit, where a 9,677-foot peak once stood, the 5th tallest in Washington. There is now a horseshoe-shaped crater 2 miles wide, open to the north like a wound that will never fully close. 57 people died on the morning of May 18, 1980. They were scientists and loggers, photographers and campers, homeowners and hikers. An 83-year-old World War I veteran named Harry Truman, who had run his lodge on Spirit Lake for 52 years and refused to leave the mountain he loved. Buried under 150 feet of volcanic debris along with his 16 cats. A photojournalist named Reed Blackburn, stationed 8 miles northwest for National Geographic, who never had time to reach his car. 94 33 31,548 42,456. A photographer named Robert Landsberg, who realizing he could not outrun the blast, rewound his film, placed his camera in his backpack, and lay down on top of it to shield the film from the heat. His body was found 17 days later. The film survived. His final images were published in National Geographic the following January. More than 200 homes were destroyed. 185 miles of highways and roads were obliterated. 15 miles of railway were ripped apart. Volcanic mud flows surged down the Toutle and Cowlitz rivers, destroying bridges and carrying so much sediment into the Columbia River that the shipping channel shrank from 4 feet deep to 14, stranding 31 cargo vessels in Portland Harbor. 7,000 large animals, elk, deer, and bears, perished. 12 million fish died in superheated rivers. The total damage reached $1.1 billion. The deadliest and most economically destructive volcanic event in the recorded history of the United States. David Johnston's body was never recovered. In 1993, 13 years after the eruption, state highway workers found fragments of his USGS trailer scattered and buried in the volcanic debris. It was the only physical trace of him ever found, and in a cruel twist of fate, the student Johnston had sent home that night, Harry Glicken, survived Mount St. Helens only to become the sole other American volcanologist ever killed by a volcanic eruption. 11 years later, in 1991, Glicken died in a pyroclastic flow at Mount Unzen in Japan. The 2 men whose paths crossed on a ridge in Washington would both be taken by the same force of nature, separated only by a decade and an ocean. But David Johnston's legacy did not die on that ridge. His work, and the work of his USGS colleagues, had kept the restricted zone in place despite intense political and economic pressure. Had the mountain been reopened, as businesses and local officials demanded, hundreds or potentially thousands of people would have been in the blast zone on that Sunday morning. The closure that Johnston fought for is credited with saving an untold number of lives. 2 years after the eruption, the USGS renamed its Vancouver office the David A. Johnston Cascades Volcano Observatory. It remains the primary monitoring center for every volcano in the Cascade Range. The ridge where Johnston died was renamed Johnston Ridge, and the observatory built there, the Johnston Ridge Observatory, stands today as both a memorial and a working science facility, overlooking the crater he gave his life trying to understand. Mount St. Helens also changed science forever. Before 1980, no eruption model had predicted a lateral blast of this magnitude. The concept barely existed in the literature. After May 18th, volcanology was fundamentally rewritten. Hazard maps were redesigned worldwide. Monitoring techniques were revolutionized, and the expertise gained at Mount St. Helens became the foundation for the Volcano Disaster Assistance Program. Created in 1986 after the Nevado del Ruiz tragedy in Colombia killed more than 23,000 people, that program has since responded to volcanic crises in more than 30 countries around the world. The mountain that destroyed itself also rebuilt the science that protects us from the next one. There is a photograph taken at 7 o'clock on the evening of May 17, 1980. In it, David Johnston is sitting in a folds chair outside his trailer at Coldwater 2. He has a notebook in his lap. He is smiling. Behind him, Mount St. Helens rises against a darkening sky, massive, silent, and 13 hours away from erasing everything in the frame. He was 30 years old. He was afraid of the mountain. He went anyway, not because he didn't understand the danger, but because he understood it better than almost anyone alive, and he believed that understanding it was the only way to keep other people safe. He was right. Every storm eventually ends, but the way we hold each other, that remains. Take care of one another. If this story stayed with you, I'd appreciate it if you'd leave a like and subscribe. These documentaries take an enormous amount of time to research, write, and produce. Your support means more than you know. Thank you, and I will see you in the next one.